My name is Pranay. I've got my background in bioengineering and a master's in business and science from KGI. I currently work as a data product manager at DeciBio Consulting, which is a boutique consulting firm focused on the life. I'm just going to stop you for a second to check if the video is fine and you guys are hearing me okay.
It's perfect. Thank you.
Good.
Perfect. Life science industry. My primary role here is to develop business intelligence tools and market intelligence products for the life science industry. A lot of the work that I do involves understanding how researchers and scientists adopt new technologies. Basically, how does science spread? To give you an example, I'm sure most of you must be aware about this revolutionary new gene editing technology called CRISPR. It's getting a lot of attention both inside and outside the scientific community, as it's poised to revolutionize medicine as we know it today. But the question I want to ask is, how did CRISPR get here? It was first used as a gene editing tool in 2012, and then since then it's rapidly spread amongst the scientific community as a tool that they've been regularly using to understand different aspects of the human biology. As you can see from this graph here, the total number of peer-reviewed publications mentioning CRISPR has rapidly expanded since 2012. At DeciBio, we use network analysis to answer questions like, how do researchers adopt new technologies like CRISPR? What factors can drive or moderate the rate of adoption of these new technologies? How do you predict the next wave of adopters? How do you identify existing and emerging influencers within the community that can help you drive adoption of this technology? Ultimately, we want to help life science companies better market products to these researchers to help them continue with their research endeavors. This particular analysis can be applied across industries and across use cases, as we will see further in this talk. So there are some pretty great resources available on this topic. Chris DeMartini has previously given a talk on network analysis on a previous Fringe Festival session. And there are some great blogs by Florian and a couple of other people from the Tableau community. What I felt was that network analysis can be still a little intimidating and visually complex to analyze. Through this talk, I just wanted to further simplify some of the basic tasks like cleaning and analysis, with the hope that network analysis becomes a more frequent type of analysis that people can apply across several business use cases. Some tools that we'll be using throughout this talk, of course, we'll be heavily relying on Excel to gather and clean the data. We'll be also using an open source software called Gephi. I'll provide a link to the website. It's a great software to conduct some basic network analysis, and it's pretty easy to learn. Obviously, we'll be using Tableau to visualize this data. We might also briefly touch upon Google Fusion tables, which is another way to view some basic network data. Before we dive into the analysis, I want to quickly go over some basics of network analysis. Network analysis is basically a collection of objects called nodes that are connected by a relationship called edges. So in this diagram, you can see there's node A, node B, and they're connected by a relationship or an edge. These relationships can be undirected in nature. For example, A is friends with B, and B is friends with A. So there's no direction between this relationship. But they can also be directional in nature. For example, friend A paid $5 to friend B for food. So this would be a directional relationship starting from A down to B. These relationships can also be weighted. For example, you paid friend C for rent. That was $500. So this arrow is considerably larger than the one between friend A and B. This is another way to add dimensionality into network graphs. Degree is another term that's frequently used in network analysis, and it's the total number of relationships or edges originating or terminating at a particular node. For undirected relationships or networks, we can see here there are 3 edges originating from node A, hence the degree is 3. For directed relationships, the total number of total number of edges originating from node A is 3, but we can further subclassify this into 2 different categories: in degree the number of edges terminating into node A, and out degree, number of edges originating from node A. So a collection of these edges, their weights, and their relationships form clusters or communities within networks. And there's some interesting trends that can be harnessed from these relationships. For example, in this particular image that you can see, we've defined example, you liking a friend's photo and the friend liking your photo back on Facebook. You can have what we call social media influencers. We can have people that bridge different clusters together, and so on and so forth. There can be different type of insights that you can gather from a network. The next thing that I want to discuss is how do you structure this data? Let's take an example. Tableau wants to better understand its viewers on YouTube. Right now, the Tableau YouTube channel has about 23,000 subscribers. Each one of these subscribers further subscribes to other channels on YouTube. There's a possibility that Tableau can leverage this data to better understand its users and then create curated content for them based on their likes and dislikes. So this is how we would structure this data. You would have subscriber A. He is also subscribed to 4 other channels apart from Tableau's YouTube channel, A, B, C, and D. Subscriber B has 3 subscriptions apart from the Tableau channel, and he's subscribed to C, D, and F. Between subscriber A and B, we can see that there are 2 common channel subscriptions, C and D. Now, we would take this data and convert it into 2 different tables, which are really common in network analysis. The first table that we would use is a nodes table. A nodes table is basically a collection of all the unique nodes in a network. It's basically a list of the different nodes that you would have in a network. In this case, it would be a list of the subscribers, subscriber A and B. The edges table takes into account the relationship between these nodes. It has 2 distinct columns called the source and the target. In this case, we have subscriber A as a source, subscriber B as a target. The type of relationship in this case, for the example that we just gave, would be an undirected relationship. The weight that we assign here is 2. The reason because these 2 subscribers have 2 channels in common, C and D. That's it. It's as simple as that. Try to structure every data set that you get into this particular format. It will be really easy to sort of export it into other network analysis tools like Gephi and then conduct further analysis. Before we move further, I just want to stress on the fact that networks can be found everywhere. They're not just in social media networks like Twitter, Facebook, or YouTube. You really can have networks in sales databases and marketing databases. You have networks in biological databases like gene structures and expressions and so on. So try to have an open mind when you look for networks. You may be surprised with the type of insights and the networks that you can find within your data set. For the purposes of the next example, our actual data analysis, we'll be leveraging on a data set which has wholesale wine sales data, and it's basically an analysis of deals and discounts given out by a wholesale winery. Throughout the year, they conducted 32 deals or marketing campaigns where they offer discounts on wholesale wine purchases. There are 100 customers in this database who individually availed about 324 deals in totality. Can we use this data to understand different customer profiles and their purchasing behaviors? And that's the question that we're going to use, that we're going to address in the next analysis. This data set and the whole idea of this analysis is taken from the book Data Smart by George Foreman. I highly recommend this book. He goes through different aspects of network analysis and gives you a little bit more background into the actual theory behind why clusters form and how do you basically conduct network analysis. So here's the actual data set. I'll be providing a link to this data so that you guys can conduct this analysis on your own later on. So let me just walk through the different columns that we have here. We have an ID column. The next column here is a customer column. It's the name of the customers, and the columns in orange are basically the actual data around the deals. So we have the offer number, the month the campaign was run, the variety of the wine that was basically offered as part of the discount, some other data around the actual discount or deal, the minimum quantity amount and the percent discount, and the origin of the wine. It's a pretty typical marketing or sales database that you can find anywhere. So let's convert this into the format that we need for conducting the network analysis. Converting it into a nodes table is pretty simple. We just need the list of customers, a unique list of customers. So this is the 100 customers that we have in this database. Plain and simple. The edges table can be a little bit tricky. The 4 columns that we really need in this table are a source column, a target column, a weight column, and the type column. This can be a little tricky when your data set is beyond a certain limit. It was easy to do this analysis for the YouTube data set, but when you start having rows and rows of sales data, it can get a little tricky. So what we're going to do here is we're going to leverage Tableau to conduct this analysis and get the edges table. Let's open this data set in Tableau. Great. So I've imported the data set into Tableau. And in order to create the edges table, what you would do is take the main database, the wholesale customer deals sheet, and we're going to reapply it to the data column here. Just redrag the sheet and join it to itself. The way that we're going to join these two data sets is the same way that we're going to form the relationship. It's through the actual offer between these two customers. So we're going to use the offer field to join these two data sets. Perfect. So in order to create an edges table, what we would do is we would start with a table called the adjacency table. We will take the customer name from the first sheet and put it under the columns row, and take the customer name from the second sheet and put it on the row shelf here. What this creates is a 100 by 100 adjacency table where we have the customers lined up, and you can see Adams, Allen, and there's a nice diagonal line that forms through customers that are similar. But then you can also start looking at relationships where you can automatically see that Adams and Bailey have some sort of deals in common. They've both taken the same discounts or deals through this particular customer, through this winery. So in order to calculate the total number of deals that are in common to both these different types of customers, what we would do is take the offer number. Let me just drag it into the dimensions shelf, put it on the details shelf here, and then count distinct. There you go. So we can see that Adams and Bailey, both of them have one particular deal in common, whereas Brown and Adams have 2 deals in common. And you can see this nice relationship matrix formed across the table here. We also have some noise in this data set. For example, Adams has taken a total of 3 deals, and we don't want that data set. We don't want Adams to be related to Adams in our network analysis. It just adds to the noise. So let's go ahead and create a calculation to remove that. If the customer name from the first sheet is equal to the customer name from the second sheet, then give it a null, else give us the offer ID, and call this unique deals by this. Right, let's take this off from the details shelf, get the unique deals, count distinct. Perfect. So you can see that we've sort of removed this noise. Let's just go ahead and remove it from the data set as well. I just don't want to see the 0 there as well. Perfect. Now you can see that we've removed the noise, and now the only thing that we have in this data set is the relationship that 2 customers have just based on the number of unique deals that they have. Great. Once you've created this matrix, what we can do is we can view this data source, and automatically you can see that Tableau has structured this data as an edge table. We have the customer name, the source column, the target column, and the total number of deals that are in common between 2 customers. Perfect. Let's just copy this data over and bring it back to our Excel sheet. paste the data here. The rows that I received, the row that I received as headers from Tableau. Perfect. The source, the target, we've got the weight. And because they're just deals that are in common between these two customers, this type of relationship would be an undirected relationship. Great. That's it, folks. We've successfully converted our sales database, our marketing campaign database into a nodes and an edges table. The next step would be importing this data set into Gephi and conduct some basic network analysis. So the next step here is that we're going to upload the nodes and the edges table, specifically just the edges table, into Gephi to conduct some basic analysis. I've opened the Gephi window here. I'm using version 0.9.1. We'll go ahead and create a new project. Just as a side note, this is not a tutorial into Gephi. I'm just showing some basic steps that I use, that I basically follow to conduct some basic network analysis. The two main windows that you need to concentrate on are the overview window and the data laboratory window here on the top. We're going to start with the data laboratory window here. Click on the import spreadsheet button and upload your edges data set, your edges sheet. Perfect. Just click on next, keep the default settings. Great. Once you've uploaded your data set, go back into the overview window. As you can see, Gephi has automatically created a basic layout of your network diagram. Let's start on the left here. You can see that there's an appearance window where we can sort of modify how our network graph looks like. We're going to go back into it in a second. You're going to start with the layout window here. What this has is different layout algorithms that are used to basically better structure the network. The most common ones are Force Atlas, and If and Hue is also a really good one. I'm going to start with Force Atlas. There are different settings that you can play around with that sort of determine how your network is structured. Because I've sort of done this before, I'm just going to use settings that I know that work. Great. Once you've created the settings, you can go ahead and click Run, and you can see that Gephi has automatically structured this data into different communities. Again, it's really hard to sort of gain any insights from here. What we can do is we can go onto the right here, and there's a statistics window where you have different functions that can be run on this network here. I'm going to go ahead and run the average degree and the modularity functions. Again, you can play around with these small features and numbers. They're really easy to follow and understand. But I'm just going to use settings that I know I'm going to work on my network. But it's really easy to figure out, what works best for your network. Modularity is performed to basically understand the different communities. I'm just going to run this, and within the results, you can see that we've sort of formed 5 different communities within our 100 customers. So these are clusters. All right. So let's display this data on our graph here. I'm going to go back into the appearance setting here. Within nodes, I want to color each node based on the cluster or community it is a part of. I'm going to go into partition, modularity. Great. All right. It's still really hard to see what's going on here. Let's go ahead and increase the size of these nodes. Or better yet, we're going to size these nodes based on the degree of each one of these nodes. Great. You can start seeing some different classes here. This particular node is really big because it's got many edges running through it. I'm going to rotate this a little bit so that we can see it better. All right, this is fine. Great. You can see that there's a pink community here, a green one, a darker green, an orange, and a blue. I'm really happy with how this looks like right now. So I'm going to stop the analysis here and import it into Tableau. Gephi is really good for conducting this sort of network analysis, but it's really hard to interrogate and interpret this data. And I want to understand, what has this customer bought? What are the different characteristics of this customer? So I'm going to go ahead and upload this network graph into Tableau. And the way to do that is to go into File, Save As, Oops. Let me try this again. File, export graph file. Yep, and I'm going to pick the JSON format. And what this would do is this would give me the X and Y coordinates of the nodes available in this Gephi file. And let me just show you that really quickly and how that data looks like. We're going to wine analysis. Oops. And let's rename this JSON file. All right, so I'm going to use Tableau to view the JSON file that I just exported. Tableau for me is more than a visualization tool. I also use it for a lot of my data cleaning and analysis purposes, sort of the pre-visualization steps. As you can see, we use it to create the edges table, and now we're using it to visualize some of the network graphs that we just performed, the network analysis that we just performed. Go ahead and open that file. I'm going to import just the nodes table here. Great. You can see that for every node, it's given me an X and Y axis. And now what I'm going to do is I'm going to follow Chris DeMartini's blogs on network analysis and how to graph these networks to create a dashboard and then further conduct this analysis. I'm going to leave links on how to create those graphs in Tableau. So this is the final step of the analysis, the actual visualization and interrogation of the data. Once we exported the data from Gephi, what I got was X and Y coordinates for each one of the customers or the nodes in the graph here. And I went ahead and plotted that as a network graph here in Tableau. There are multiple blog posts on how to use the patch shelf to make this graph, and I'll link those below. It's a fairly simple process once you have the nodes and the edges table. We then overlaid some of the other data points from the main database, such as the average discount rate, the minimum quantity ordered, the month of the campaign, and the top 10 deals. So a traditional analysis would only look at these particular data points and try to find insights. But now that we've conducted this network analysis, let's go ahead and explore the data set here. Starting with cluster number A, you can just focus on that, and what this does is pulls up the clusters, and you can automatically see who the different customers are in the segment. You can look at their spending patterns. They usually buy a lot in September, October, and instantly you've already gained one insight. They're really interested in Pinot Noirs. I apologize in advance for my pronunciation around these wines. I'm not too familiar with these names, unfortunately. I'd rather stick to a beer. All right, moving on. Going on to cluster B, let's see what's happening here. Cluster B is interesting. We can see that most of the finds that in this particular cluster are from France, the top 3 wines at least. Cluster C. Cluster C is interesting. I had to Google this up, but most of the wines, the top 5 wines at least, are bubbly wines, Champagne, Prosecco, and Espumante. So that's an interesting cluster. These customers are interested in buying bubbly wines or sparkling drinks. Sorry. Let's look at cluster number D. Interesting. I don't know if you guys have been noticing, but this cluster has an unusually low minimum quantity. Let's toggle back between cluster C. So the rest of the clusters order somewhere around 68 to 75 kgs, but cluster D, they are minimum quantity buyers. They really look for lower quantity deals within the wholesale wine market. And finally, let's look at cluster E. Whoa, again, so these guys are bulk buyers. They really require larger quantities within their deals. All right, let's visualize this network at once and see what type of analysis that we've been able to gather. So right here on the right cluster, these are your low volume buyers. Their average quantity order of their quantity is around 32 kilos. Moving on to the next cluster, which is the orange one here. This cluster was the French wine cluster. The red cluster here are customers that really enjoy sparkling wines. We have your bulk buyers here. The minimum order within their quantity is about 94 kilos. And then finally, the Pinot Noir clusters. So with this data, armed with this data, the winery can make specific targeted campaigns to each one of these customer groups. Now that they understand their buying preferences and use this data to sort of drive their innovation within their marketing campaign, they can also use this data to develop new products, new wine lines, and this data can also be applied to several other sales databases. So you can imagine you can use this data within pharmaceuticals, you can use this data within cars and buying patterns within cars and so on. So network analysis is pretty powerful, and as we sort of demonstrated, it can be expanded far beyond social network analysis and take into account different databases that we have. I'm going to link out to the different resources used throughout this talk. Thank you so much for this opportunity. Let's take questions now. All right. Thank you so much, guys. That's the end of my talk here.
Hi, that was incredible. So I've just been trying to watch intently along as I've been seeing everything come together. It is amazing. I never really thought about, how we could potentially use this to analyze customer behavior, but having a look at what you've done there, I've seen it a lot more in social network analysis and what goes on. So oftentimes people take a look at what's happening on Twitter. I know they do a lot at the Tableau conference and also at the Ultrix conference, and seeing how everyone's kind of interacting, and then the size of the bubbles are, is depicting the kind of people that are the higher influencers along the way. But this really brings another lens on it. So thank you so much for the
My pleasure, yeah.
Great.
Thank you so much for giving me this opportunity, and it's been a pleasure.
Yeah, so I've like the chatter that's kind of been going on when we saw it come through into Tableau. There's such a difference in seeing it in Gephi and then it coming through and getting that interactivity that you've got and pulling out the JSON file. It's really cool. So we've got lots of people that are sharing how amazed they are. I think everyone's jaws have dropped quite a bit.
That's good. That's good to hear.
And can you tell? There's not any Q&A questions, but I'm curious. So, have you found that there's lots of customers that have been interested in this type of analysis?
Definitely. I mean, we work with a lot of companies that are trying to understand how researchers collaborate with each other. And the example that I just started with during the first half of the presentation was around CRISPR, which is a really new, gene editing technique that not a lot of people know how to harness and how to use. And we've been working with companies trying to point them to the right people. We've been using this sort of network analysis to identify different clusters within these researchers. So, for example, within CRISPR, you've got this core network who, those researchers who actually discovered CRISPR and who've been like pushing forward this technique. And then suddenly, after a few years, you start seeing these fringe networks that start appearing. And what's interesting to us is, trying to decipher how they got about learning that technology, what drove them to adopt that. And companies themselves are really interested to understand that, because it takes, your two-dimensional analysis to another level. You start thinking from the customer's perspective, what does this customer profile look like? What does he feel? What are their behaviors? How can we serve them better? So there's been a lot of interest in sort of understanding customer behavior, and there's a lot of data there that's got hidden network data, as I say, and you just have to find it out and see if you can derive any insights from them.